Rob. Welcome everyone. So as Rob mentioned, this is the third webinar on fall protection plans and system implementation. So if you're interested, we did the first two webinars that recorded on the AMHSA website, so you can go back and listen to them if you want. So my name is Brendan. As was mentioned, I'm a senior engineer with High Engineering. I'll be presenting today. So what we'll look at today, we'll talk about fall protection plans, what they are, what they require. Then we'll talk about benefits and limitations of the different system types that we talked about in webinar 3. Then we'll talk specifically about anchors and anchor strength, what to look for in anchors. And then we'll close off with questions to ask manufacturers and contractors. I'll start with a bit of a disclaimer. So this is only for information and awareness only. It's to help you have a general understanding of what fall protection is, what questions to ask, to learn what you need to go get more training on, consult an outside expert. So it's only for raising awareness. I'm not providing any legal advice or any specific advice for your specific scenario or location. If you do use any kind of fall protection, it does require in-depth training beyond what we cover in this webinar. So you need to make sure you have the appropriate training. And you can always consult an authorized training provider to get that detailed training. There's a bit of a review on what we've covered so far. We had webinar 1, which was identifying slip, trip, and fall hazards. We talked about identifying the hazards, recognizing different hazards, and then some common hazards and examples at aquatic centers. And then in webinar 2, we talked about the types of fall protection, including guardrails. So we had a brief introduction to a fall protection plan and training requirements. We talked about the hierarchy of controls. And then we looked at details on specific systems like guardrails, travel restraint systems, fall arrest systems, and then some other miscellaneous controls. So if you're interested in any of those topics, I would recommend going to the AMHSA website. Those webinars are recorded, just like this one will be, and you can watch them at any time that's convenient to you. The main thing regarding fall protection regulations, they're all covered in Part 9, specifies when fall protection is required. So the employer must ensure that you as the worker are protected from falling if you may fall in any one of these conditions. So if you may fall a vertical distance of 3 meters, which is 10 feet or more, if you may fall a distance of less than 3 meters onto any surface other than a flat, solid surface, so that, an uneven surface or some kind of dangerous surface. If you may fall onto a hazardous substance or object. If you may fall through an opening. And if you may fall a vertical distance of 1.2 meters or 4 feet or more at a permanent work area. So if any of those conditions are true, you do need fall protection, which, as we talked about in webinar 2, we talked about a bunch of different types. And now this webinar, we're going to focus a lot on the fall protection plan. So, we've identified the hazard, we've talked about the different systems we're going to use. Now we need to actually develop this fall protection plan for how we're going to use the system we have selected. The fall protection plan is outlined in section 140 in the Alberta OH&S code. And this states that if a worker, so the plan is required if a worker may fall 3 meters, 10 feet or more, and is not protected by guardrails. So falling any height, if you have guardrails, you do not need a plan because the guardrails don't really require any additional instruction. But if you're using anything else other than guardrails above that 3 meter mark, you need fall protection, or you need a fall protection plan. And then it's also required that the employer must develop this plan. So if you're a worker at a work site, you can ask the employer, they have a responsibility to provide this plan to you. And the plan must be available at the work site. So it has to be available for easy reference. If you have questions about something you're doing as you work through your job tasks, you can refer to that plan, make sure you're using the equipment correctly. And then all workers must review the plan before the work begins. So this is typically, your pre-start meeting or your toolbox talk or whatever it's called. you review through the plan, what you're going to be using, what procedures you're going to use, where everyone's going to be working, just to make sure everyone knows all the steps up. And then the plan also must be updated when any conditions change. What is required in this fall protection plan? So the regulations state that it must specify all of these following items. It must specify what fall hazards are present at the work site. So if you want more detail on different fall hazards, I'd refer you back to webinar 1, where we talked about hazards in detail. It also must specify the fall protection system that is going to be used. So, if that's a fall arrest system, a travel restraint system, something else, needs to detail what that system is and what equipment that consists of. So if you're using a lanyard, if you're using a self-retracting lifeline, if you're using a vertical lanyard or a vertical lifeline, any of that equipment needs to all be detailed out in the system description. And again, more details on the different types of systems can be seen in webinar 2. So if you need, you can go back and refer to that webinar. And then it also needs to specify what anchors need to be used. And that's a large portion of what we're going to talk about in the second half of this webinar. So what are the requirements for anchors, anchor strength, some of those details, but that needs to be listed in the plan. And then also needs to specify the clearance distance below the work area and ensure it's sufficient to prevent you from striking the ground or an object below the work area. So, if you're using a fall arrest system, you could fall, but the system's going to arrest your fall. It needs to show that it's going to stop you before you actually hit the ground. We talked a little bit about clearance in webinar 1 when we looked at identifying hazards, but calculating clearance is a very in-depth topic. That'd be something that's covered in a general fall protection course. So if you need more detail on that, I'd recommend taking a course. They'll teach you all about how to calculate clearance for the different types of equipment. Also need procedures for how to assemble the system, how to maintain the system, how to inspect the system, how to use the system, and then finally how to disassemble the fall protection system. So all of those procedures need to be listed in your plan. And that's so when the employers review or the employees review it at the start of their work session, they can see, okay, I need to set up the system. How do I set it up? Once it's set up, how do I use it? Do I need to inspect anything? All those details are listed in there so that it can be used safely. And then it also needs to include rescue procedures. So this is, once or if someone does actually fall, how do you rescue them? Because the system's not very effective if someone falls, but then you don't have an emergency plan and rescue plan to get that person out of suspension from the fall system. And we did talk a bit about that last time in webinar 2, but calling 911 is not a sufficient rescue plan. A lot of people, if they haven't taken enough training, they'll say, well, we'll just call 911. There's a lot of potential issues with calling 911 for your rescue plan. Depending on your location, if you're in a rural setting, 911 might not be readily available. It might take them half an hour or an hour to get there depending where you're located. That's much too long to leave someone suspended in the system. Also, depending on the type of system, 911 might not generally have the right equipment. A great example of this is if you're extremely high height, you call 911, they might not send the ladder truck with the very tall ladder to get to you. So it always needs to be pre-planned. You need to make sure whatever your rescue plan is, they'll have all the necessary equipment and can get there in a sufficiently short amount of time. So the Alberta government, as part of the OH&S code, they've actually published a guideline or a template for this fall protection plan. So there's a QR code on the screen. If you want, you could scan it. It'll give you a link directly to this template. And it covers all those topics as required. So what hazards are at the work site? What system are you using? What are your anchors? What are your procedures? It includes a template to help you calculate clearances. So all that's in there. As a reminder, though, it is just a guide. So if you don't know how to write a procedure, you can't just refer to the template and hope that'll give you the right instruction. If you don't know, I recommend consulting an expert or taking some training to make sure you can fill it out correctly in application. So now we'll look at an example. We'll look at an empty pool basin. We discussed this exact scenario in webinar 1 when we talked about identifying hazards. So we'll use the same scenario. If you were working at the far side of the pool where that X is to kind of unload and prepare materials so you could repaint the pool. We talked about hazards. We said, there's the hazards of falling. We talked about weather, slips, all those details. Now that we've done our hazard assessment, we said, okay, we do need fall protection. Now that we've done fall protection, this is what our plan is going to be. So first thing we need to decide is, do we actually need a fall protection plan? If we're using a guardrail, so if our solution was, we're just going to put a temporary guardrail around the perimeter of the pool and then the whole pool is protected, we do not need a plan because there's a guardrail. Likely, because we're painting the inside of the pool, we need some way to get our material into the pool. So a guardrail isn't going to be a perfect solution, or at least we'll need a gap in the guardrail to lower that material into the pool. And in that case, we need some other form of protection. And then the other thing to think about is technically we only need a plan if we're falling over 3 meters in height. So at the shallow end, it's probably only about 1 to 1.5 meters high. Technically, we would not need a fall protection plan then. We still need some kind of fall protection system, but we don't necessarily need a plan in accordance with the regulations. Best practice would say you still need a plan no matter what, because you still need to know how to use whatever system you're using, what equipment to use with that system. You still need to calculate your clearance and your rescue plan. So best practice is anytime you're using a fall protection system other than a guardrail, you should have a plan. Not legally required, but recommend. And then the other thing is, if we're working at the far side of the pool at this red X, we might only be falling 1.5 meters. But if we come over to the near side of this photo where it's deeper, we can see the pool gets deeper. Maybe it's 3 meters at this end for a diving board. In that case, we would legally need a fall protection plan as well. So in this case, we're going to assume we're working around the entire pool. So we might fall 1 meter, we might fall 3 meters. We're going to develop a plan. And I'll talk through the different points of the plan. So as I already mentioned, we're preparing material to clean and repaint the pool. We talked about, do we need a fall protection plan? So the first item, what is the fall hazard? The fall hazard is falling into the pool. As I mentioned, we talked about this in webinar 1, but we need to identify that in our plan. The hazard is falling into the pool. Is there any other hazards associated with that? Where are workers going to be working that are going to be exposed to this hazard? So we'll list that in the pool. So, maybe there's 2 workers here. The pool's going to be closed for a week. There's only limited staff. If these workers are present, they're going to be working at the X or around the whole perimeter. They're exposed to falling into the pool. What fall protection system are we going to use? In this case, let's say we want to use a travel restraint system. So travel restraint system means it will restrain our travel so that we can't actually get to the fall hazard from falling. For loading and prepping material on the edge of the pool, this is probably perfect because we don't necessarily need to climb into the pool. If we were climbing in and out of the pool, that wouldn't work because then we would be at the edge of the pool and could actually fall in. But, we see those blue barrels there. We're assuming those are paint barrels or supply barrels that we're loading, preparing to load into the pool. So we could maybe set up a travel restraint system. We could have a couple of anchor points on that wall of the building behind us, connect with a lanyard or a vertical lifeline, and then ensure it's adjusted so that we can't actually fall into the pool. Then, we can travel back and forth from the storeroom in this building, bring our material to the edge of the pool, place it there. That's our job task. So that will protect us. So then the next step is anchors. I've already mentioned this, but we'll pretend we have some anchors installed on the wall of this building. Those would be something that, let's say we hired a contractor, the contractor came in, put some anchors into that wall. we'll talk about details of what those requirements need to be later in this presentation, but for now we'll say there's anchors there. Our procedure is going to be there's an anchor socket, you just screw your anchor into the wall, that's your installation procedure, and then you connect your vertical lifeline to the anchor head. That's how we set up our system. And those are our anchors. Next, we need to talk about the clearance. So because we're using a travel restraint system, we said it's designed and adjusted so we cannot fall into the pool. So we don't have to calculate clearance because our fall distance is 0. We're not going to fall, which is perfect because at the far edge of the pool, where maybe it's only a meter deep, there are very few, if not no, systems that actually arrest your fall in that short of a distance, which is probably why we decided to use a travel restraint system in the first place. But that's something to consider. Maybe if we started by saying we want to use a fall arrest system, we pick our fall arrest system, and then when we get to this step, we calculate our clearance, and we say, oh, in our clearance calculation, we need 5 meters, which is not an uncommon number for a standard fall protection lanyard with an anchor point. If we need 5 meters of clearance, and we only have 1 meter, that is not going to work. So as part of developing this plan, we could see that, and then we'd say, okay, fall arrest system is not safe, not going to work. So we need to go back and change what kind of system we're going to use. We'll change from a fall arrest to a travel restraint system. Then we don't have to do or worry about our 1 meter clearance. And then our system is safe and we can move on to the next step. Next is our procedures. So as I mentioned already, our install procedure is going to be screw in our anchor heads into the wall sockets that have been installed by a contractor, and then connect our vertical lifeline to those anchor heads. Our usage procedure, there'll probably be a bunch of steps, but very simplistically, it'll be something along the lines of put on your harness. Actually, you'll start with inspecting your equipment, most likely. So, and that is one thing we need to talk about is inspections. So there'll be some details about how to inspect your equipment, what equipment to inspect, inspecting the anchor sockets and the anchors. Then, putting on your equipment. So put on a harness, connect the vertical lifeline to the anchor, connect it to your harness, and then some procedures on how to adjust it, depending on what kind of adjusting device we have. And then how to adjust it to make sure it actually functions in travel restraint. So this usually involves some kind of distance, adjust it to be, let's say, 2 meters long, double check that at some safe location, and then you can start working. And then disassembly will usually just be the reverse. Take off your equipment, unscrew the anchor. That's okay. Then our last requirement for a fall protection plan is the rescue. So in this case, because it's a travel restraint system, not a fall arrest system, the worker's not going to fall, they're not going to be suspended, so we don't need to rescue them from hanging in the system. But we still do need some kind of emergency plan in case something else happens to the worker. So let's say in the picture, it's a sunny day, probably summer. What happens if the worker's working there? It's hot, it's sunny, it's a large concrete area. So they get some kind of heat stroke or heat exhaustion and pass out. How do we safely get that worker away from the edge of the pool surface without exposing the rescuers to hazard? So we need to address them. In this system, it could be something as simple as someone walks right along the edge of the building, so they're a couple meters away from the edge of the pool. They're not really exposed to that fall hazard, and then they can just drag the worker by pulling on the vertical lifeline and drag them away from the pool hazard without actually going to the hazard themselves. And then once they're safely away from the hazard, we can administer first aid. We can call 911 if needed to treat other medical issues. So in that case, 911 is part of the rescue plan, but it's only part. It's not the whole plan. It's not, oh, I see someone's passed out over there, I'm going to call 911 and do nothing else. That would not be sufficient. But if we have another plan to get them to safety, kind of administer some first aid, look after their immediate injuries and immediate threats, and then that gives time for 911 to get there and do what 911 does best, providing more in-depth first aid, secondary aid, transport to hospital, those kind of things. That's a perfect use of 911 as part of your rescue plan. So in general, that's a very kind of quick and simple approach to everything you need in your fall protection plan. The next thing we want to look at are the benefits and limitations of the different system types. So we'll start out with guardrails. Again, we talked about all the different systems in webinar 2 and what they consist of. So guardrails, one of the main and probably the biggest benefit is that you won't actually fall. The guardrail is just there. It prevents you from getting over the edge and falling. There's also no fall protection plan required. As we saw in the legislative requirements, if you're protected with guardrails at any height, you do not need a plan. Part of that is because you don't really need instructions how to use guardrails. The instruction is don't climb over them, which everyone should know and should have been taught. We don't need to write that. As part of that, there's no training. So like I said, you don't need training on how to put on a harness, how to select it, how to calculate a clearance, all those details like you need for other fall protection systems. You don't need to go to a training course on how to use guardrails. There's also no additional personal protective equipment required. So you do not need a harness and a lanyard, a vertical lifeline, all these other pieces of equipment. Again, it's just there, it exists. For the most part, you don't even need to worry. Some of the limitations are they can be an expensive upfront cost, especially for permanent guardrails, because you need to pay usually some contractor to come out, do the installation. There's potentially steel work, potentially concrete work. Maybe there's woodwork, depending on what kind of guardrail is. But that can be a large lump sum cost to get a permanent system installed. They also only work on solid flat surfaces. So if you're working up on, let's say, a large play structure on a slide, it's very difficult to put a guardrail around a slide that's going to prevent you from one sliding down the slide or one falling off the side of the slide, especially if it's an enclosed slide and you're working on top of it. It's a round, uneven surface. It'd be very difficult to mount guardrails there for one, and then very difficult to mount them effectively so that they can actually prevent you from falling off that surface. But something like a pool deck where it's flat, it's solid, great place for guardrails. And then the other thing is you usually need some kind of additional protection to set up guardrails. So even if it's a temporary guardrail, maybe we said, like in our empty pool example we just looked at, we're not gonna have permanent guardrails, so we don't need to worry about paying someone to install guardrail sockets and installing all this expensive guardrail. We're just gonna rent it for the week. But then we need to figure out a plan of how are we going to set up that system. And that's something that people can often miss is with guardrails, you do not need a fall protection plan for using the guardrail, but usually you need to use some kind of travel restraint system or fall arrest system to safely set up the guardrail system. And you do need a plan for that, along with all the other equipment and training for setting them. So that's something to consider. You can't just say guardrails, we don't need a plan, we're safe, we're happy. You have to consider every aspect of the use of the system. And then for reference, here's a QR code. AMHSA produced a one-page poster on the different requirements for guardrails. So you can scan that. That'll take you to that poster as a quick reference guide for everything you need for a guardrail system to be compliant. Next system we'll look at are travel restraint systems. So as we mentioned in webinar 2 and already in this presentation, the main purpose of a travel restraint system is to prevent you from getting to the hazard. So, you connect a lanyard or a vertical lifeline and harness all your equipment, and then allows you to work, but does not allow you to actually reach that fall hazard and fall. So similar to guardrails, probably the primary benefit is you will not actually fall. So that prevents a lot of injury, lots of potential complications with rescue and being suspended. You just don't fall, so you don't have those hazards with this system. There's also no rescue plan required because you don't need to rescue someone from being suspended. You still need an emergency plan for, other health consequences as part of your general safe work practices, but you don't need a fall protection rescue plan to rescue a suspended animal. And as part of that, you don't need all the additional training for rescue training, a specific rescue crew, anything associated. They also work with minimal or no clearance below the surface. So like we saw in the pool example, if you're only falling 1 meter, it's very difficult, if not impossible, to find a fall arrest system that works in that scenario. But if you can use a travel restraint system, you don't need to worry about what your clearance restrictions are. And they can be cheaper up front, because really, like in our example, you maybe need to pay for a couple of anchor points, which is likely going to be cheaper than a full 50 or 100 meter guardrail around your entire pool. And you need to purchase, maybe 1 or 2 harnesses and 1 or 2 vertical life lines. So they can be cheaper up front. Some of the limitations are they do require additional personal protective equipment. So like I've talked about, you need your harness, you need your lanyard, a vertical lifeline, you need anchor points. I guess it's not equipment, but you need all this other personal protective equipment as part of the system. They generally will require a fall protection plan. As I talked about, they may not legally require a plan in every case, but as best practice, I would recommend a plan anytime you use it so you know how to use the system safely. They do require in-depth training. So if you're going to use a travel restraint system, you need to be trained on how to put on a harness, how to safely use the vertical lifeline or the lanyard or the self-attracting device, how to connect all your systems properly. You do need to go to a fall protection course.
Oh, Brendan, there's a pop-up that came up on your screen that's on the recording.
Oh, thank you, Rob.
No problem.
So they do require training. The other thing is they require regular inspections. So typically a system will require an inspection annually. So every year you need to have someone come out, or you may have someone on staff to do this, but you need someone doing full inspection of the system. So this can add to the cost, especially if it's someone external, you're contracting a third party to do your inspections. It's cheaper up front because you have less equipment to buy, but you need to pay for an inspection every year, which will add up. It's also something you have to make sure you get done. I see a lot of the time, unfortunately, you go out to a site, they've called us out to do an inspection, and we asked when was this last inspected, and they either don't know or it was like 10, 15 years ago. That means there's been people who have been using a uncertified, uninspected system that may have faults and damages and could be unsafe. So it's something you have to remember to do, and then you have to pay to do usually as well. Here's another QR code to the poster that AMHSA has produced for travel restraint systems, outlining all the different parts of the system. And then our next system is fall arrest systems. So one of the benefits of these is they can allow greater mobility. With a travel restraint system in particular, its purpose is to restrict your movement so you don't get to the edge. One complaint from a lot of workers is, well, then it's awkward to do my work. And depending on what kind of work you want to do, that may not even be feasible. In our example, we said, we're not entering the pool, we just need to get material to the pool edge. That's great for travel restraint. But if we need to actually climb into the pool, then we need a different system. Or like I was talking about, working on top of a slide. In that case, travel restraint probably won't work because basically to not fall, you can't move. In this case, you can use a fall arrest system. It will allow you to fall, but it will also allow you to maneuver around, especially on something like a slide or something high up. You can kind of climb up and around and over and anywhere you want and still be protected. Like travel restraint systems, these can be cheaper up front because, again, you're only buying a couple pieces of equipment and maybe installing a few anchors. In terms of limitations, they do require all that additional personal protective equipment. So again, your harness, your lanyard, your vertical lifeline, anything like that, you do need to have that equipment. They require a fall protection plan. Similar to travel restraint systems, maybe not every possible case if you're falling less than 3 meters, but best practice and my recommendation would be to have a plan anytime you're using a fall arrest system. They do require in-depth training. So again, you need to make sure you go to a proper fall protection training course. These systems do require a rescue plan. So like we talked about, once you've fallen and are suspended, there needs to be a plan to rescue that fallen worker and get them back up or down to safety, and then do whatever emergency protocols you have to follow. And like travel restraint, they require regular inspections as well. Here's the QR code for the fall arrest system poster, aligning all the different parts of those systems. Now we'd like to move on and talk about anchors. So anchors are a critical part of particularly travel restraint and fall arrest systems, which we would call active fall protection systems, because this is what you are connecting to. If you don't have an anchor, the system's not good. We'll start with a couple definitions. So first, and these definitions come from the Alberta OHS code. So anchor means an engineered component for coupling a fall arrest or travel restraint system to an anchorage, which is great, but what does an anchorage mean? So then an anchorage is also defined. It means a structure or part of a structure that is capable of safely withstanding any potential forces applied by a fall protection system. So if we take, for example, the easiest way to visualize this is that anchor strap wrapped around the I-beam at the top center of this picture. So in this case, the I-beam, which is the big structural member, it's a beam in your building, or maybe a building column, whatever it is, it's a big structural member. That would be the anchorage. It's the part of the structure that can safely withstand whatever fall protection forces were applied. Then the anchor would be the anchor strap that's wrapped around. So it's the part of the system that's going to transfer the forces from the system to the anchorage. So it's very kind of convoluted definition. The main reason it's there is because once we get looking into forces, it kind of affects how we do things. And for most systems, we can break it down. Like the anchor strap, we've got an anchor, which is that strap, and then the anchorage, which is the beam. Looking at the other images in this photo, if we look at the top left, we've got this big overhead rigid rail system. In this case, the rail itself would be the anchorage. And then we would probably also classify the posts and the arms as part of this anchor. Sorry, I said that wrong. The rail would be the anchor. And then the posts and the arms would be the anchor. And then the anchorage would be the ground. So, the rail, the posts are all transferring the forces from our system and from our, probably an SRL, self-retracting lanyard on that system, down to the ground, which is, very large, very capable of withstanding any forces that are applied. Next, if we go to the top right, we've got this anchor post with a nice anchor head with a ring on it. So in this case, the ring and the post would be the anchor. That's what transfers the forces from the system to the structure. And then the anchorage would be, the roof beam or the concrete roof slab or whatever this post is mounted to. Similar, if we go down to the center left and then very center, we've got two different style of rings. This ring itself would be the anchor. And then, the concrete wall that you see in the left, maybe it's a beam it's bolted onto, or whatever structure it's bolted to or secured to would be the anchorage. And then finally, on the bottom there, it's the bottom right, we have some temporary systems. So these, it's just a large counterweight system. On the left, we've got some large concrete blocks with a horizontal lifeline connected to them. And then on the right, we've got a manufactured portable or temporary anchored on roof sheets. So in those cases, the anchor is the concrete blocks or the counterweighted system, and then the anchorage is the ground or the roof surface it's sitting on. So hopefully that clears things up. At the end of the presentation, I'm happy to ask questions because I know it's a very confusing, convoluted topic. I even used the words wrong in this presentation, so it's very easy to mix up. Part of the reason for differentiating it that way is in most of these systems, as you can see, what you are going to go out and purchase from a supplier or a contractor is the anchor. You're going to go purchase the anchor strap or the ring or the temporary portable anchor that you're going to install. And then the anchorage is already part of your building or part of your facility. So that's the main differentiation. If we look at permanent anchors, and it is important to note, the legislation talks always about anchors in terms of strength and requirements. And then the only kind of addition to that is it says the anchorage must be able to support whatever loads are applied to it. So basically, whatever applies to the anchor applies to the anchorage as well. Like the legislation primarily talks about the anchor. So whatever device you're going to go purchase. So in this case, let's say you want to purchase some anchor posts. So the requirements for permanent anchors, and these all are for a single worker. If you've got multiple workers, then you just need to multiply it by however many workers you have. So it needs to have a strength of 16 kilonewtons or 3,600 pounds, or 2 times the maximum arrest force. If you're looking at 2 times the maximum arrest force, that needs to be either per specifications from a manufacturer or an engineer, because they would be the ones qualified to actually determine what that maximum arrest force is, and then what is strong enough to withstand 2 times that force. And the other important note is that for horizontal lifelines, HLLs, there's a bunch of additional requirements. Part of that is they always need to be designed by an engineer or the manufacturer, just because the cable and the deflections associated with that make it much more complicated than just a simple force that can be put in the legislation. Then looking at temporary anchors, they do differentiate between travel restraint and fall arrest anchors. The travel restraint anchors need be able to withstand a force of 3.5 kilonewtons or 800 pounds, and they need to be per the manufacturer's or engineer specifications. So, let's say this beam strap we have in the picture, or anchor strap, you could go buy that anchor strap from a manufacturer, and you just need to make sure it can withstand 3.5 kilonewtons, which will be in the manufacturer's literature. And then, like I said, that requirement is only for the anchor, but whatever you connect it to, in this case, the beam, needs to be able to transmit those forces and withstand those forces. So it also would need 3.5 kilonewtons, which the manufacturer will either give you recommendations on what is suitable to connect to, or you can consult an engineer. And then these temporary anchors need to be marked for travel restraint only. They also need to be removed as soon as possible. Because it's temporary, you can't just leave it there indefinitely. It actually needs to be temporary and removed once the job is done, or whatever set period you've set out for your definition of temporary. Then for fall arrest systems, these requirements are actually the same as for permanent anchors. That's because with fall arrest, you have the same forces, whether it's permanent or temporary. So it still needs to be able to withstand 16 kilonewtons or 2 times the maximum arrest force. The main reason travel restraint anchors have a lower force for temporary anchors is because in travel restraint, because no one's falling, the forces are lower. But in permanent cases, they said everything should be rated for the maximum forces, which is fall arrest, because it's permanent. Again, because they're temporary, they need to be used in accordance with the manufacturer's or the engineer's specifications. And these also need to be removed as soon as possible. So those are the requirements for strength. Another important thing is, what is the material? Is it suitable for the environment? So this is a very interesting example. This is actually a system we inspected a number of years ago at an aquatic facility here in Calgary. So in the top image, you can see, so this is a wire rope system installed over a water slide. And what they did is they used stainless steel cable in the pool environment. It was a chlorine pool. And unfortunately, stainless steel, at least many types of stainless steel, not all types, but many types of stainless steel, react very negatively in a chloride environment. So you can see in the top picture, this was actually in service condition. You can see there's a number of strands of the wire rope in this termination that have broken. The strands are starting to poke out. So we removed the system, replaced it all with galvanized cable because the galvanization does not react the same way in the chloride environment. And then the bottom picture, you can see what it looked like. We took the ropes down and then just looked at them in our shop. And you can see once we untwisted it, there's numerous broken strands throughout the entire thickness of this rope. So definitely not safe, definitely a safety hazard. And that's a great example of making sure, because we're working in aquatic environments, there are a lot of moisture, a lot of potentially harsh chemicals, whether it's a chlorine pool, could be a salt pool. Salt water is also very corrosive. There may be other chemicals as well. So that's an important thing to make sure that whatever anchor we're selecting also goes for our other equipment. It needs to be strong enough, but it also needs to be suitable for the environment we're placing it in. That's something that the manufacturer should be able to specify. They should have some kind of table, hopefully in the literature, that says, this version is suitable for environments A, B, C. This other version is suitable for environments D, E, and F, or however. If not, you can always call them. If the manufacturer doesn't know, then it's probably best to consult an engineer or some other specialty consultant. So the final thing we want to talk about is what questions to ask. So we'll start with, what do you want to ask the manufacturer? And the first thing is, how strong is your anchor? Is it going to meet the regulations? So is it 16 kilonewtons, or if it's a temporary trowel strength, is it 3.5 kilonewtons? Is it strong enough to meet the regulations? You can also ask, what standards is it certified to? So is it, CSA standard, an ANSI standard, an EN standard? A couple of standards you can look for. CSA, there's the Z259.15, which is all about anchorage connectors. Unfortunately, there's not a lot of anchors that are certified to that standard, but it is an option. Then there's also ANSI standards, EN standards. So you want to check, ideally you want it certified to one standard or multiple standards, but at least one. Is it suitable for the environment? So like we just talked about, is it a applicable and compatible material? How do you install the anchor, or who can install the anchor? Some manufacturers have special requirements for installing their systems. You either need special tools, you might need to be a certified installation partner. So some companies will not let just anyone come and install their system. They want it to be a certified installer to make sure it's actually installed correctly. Once you're purchasing a manufactured anchor, there's a couple things you need to consider. So, you can go out, you can talk to a manufacturer, you can say, okay, I'm going to buy this anchor strap or this D-ring. But there's a bunch of other things you need to consider if you are purchasing and then dealing with it yourself. So you need to decide where to install the anchor. So you're therefore responsible for the system design and the system layout and making sure it actually works. Someone needs to verify the structure is strong enough. So who's going to do that? If you are going out, buying an anchor and installing it on your structure without any outside help, you are responsible for that. So do you have the skills and the capability and the qualifications to determine? If not, you probably need to go consult an engineer and say, is my structure strong enough? And then also, who is going to specify the equipment to use with that anchor you purchase? Are you going to use a lanyard? Are you going to use a self-retracting lanyard? Are you going to use a vertical lifeline? Who's going to specify that? And then who's going to develop the fall protection plan? So you've got your anchor, you've got your equipment, but you now need to develop the plan. That's something you can do or something someone else can do, but you have to make sure it is done. And then also, who's going to train the workers? So we haven't talked about training a whole lot, but the OHS code does require that all workers be trained generally to use the fall protection system. So, generally how to put on a harness, how do you calculate clearance? But the code also requires that workers be instructed in the specific system they're using for that specific hazard. So you need to make sure either you do that training or you bring someone else in to do it. And then who's going to complete the inspections of the system? So are you going to have to go find another third party to do that? Do you have the qualifications to do that? So the employer is responsible to make sure all of these items are taken care of. That doesn't necessarily mean they have to do it themselves, but they're responsible to make sure this is all done. So you can just go to a reputable manufacturer and purchase an anchor and purchase a harness and use them. But you need to make sure this is all done. So if you don't have these skills, you need to make sure you either take the appropriate training so you can do these items, or you can also just consult an expert. So, you can hire a contractor and say, I need a system, and it needs to be more detailed than this, but I need a system that, meets these requirements. Can you please provide the system, the equipment, the training, the structural evaluation, and just get them to do all of it. You just need to make sure that somewhere along the way, either you're doing it or the consultant is doing it. So then the next logical thing is, what do you need to ask these contractors or engineers? Check on their qualifications. What are their qualifications? Are they an engineer, or are they just a technologist, or are they just someone who's doing work? There's the whole range of people. If you're doing a structural evaluation of your building, you're going to want an engineer. But then the other thing is, are they an engineer with experience in fall protection? A good example of this is, you wouldn't go and hire a software engineer to structurally evaluate your building. You'd want a structural engineer. But you should, if possible, and it's usually possible, get an engineer with experience in fall protection. Fall protection is a fairly specialized field. If you get someone who's never designed fall protection before, maybe they're a bridge engineer, they have no problem designing bridges, but they might not have the familiarity with fall protection equipment and the different regulations. So always look for someone with some experience and expertise in fall protection. So as I mentioned, do they have experience with fall? That goes for engineers, but also just general contractors. If you're hiring someone to install some anchors, you can find a lot of people who can drill and bolt in a socket to a concrete wall. But if you're getting them to do the whole system design, like we talked about on the last slide, do they have the expertise to know where the best location to put them is, what equipment to pair that with? They might be very competent in installing in concrete or doing, some welding, but do they have the other competencies as well? So make sure they have experience with fall protection. And then figure out what the whole scope is. Are they just supplying the equipment? Are they just installing the anchor? Are they doing everything? Are they supplying? Are they installing? Are they developing the plan? Are they, everything we talked about on the last slide? Make sure that's fully defined when you're picking a contractor, and make sure they have the capability and the competence to do all that. Maybe they can supply and install the system, but they don't do any training. So then you need to figure out how to do training yourself, or to find someone else to do training. So make sure you ask if they can do every part of the process. And then can they actually design the entire system, or do they just install it? And if someone else needs to design it and tell them where to put the anchors. So I'd recommend, if they are designing the system, the best standard to do that would be using the CSA Z259.16 Design of Active Fall Protection Standard, Protection Systems Standard. So this outlines, how to calculate strengths, how to evaluate clearances, how to select the proper equipment. So ideally, you'd find a contractor who has familiar with this standard and has designed other systems using it. And then if they design to this standard, it will be more than compliant with the OHS. And another question asked is, can they do any maintenance or inspections on the system? This isn't necessarily required, but it could be nice. If you have the same person install it and then do the maintenance and the annual inspection, it just helps with continuity. If you're, always changing every year who does the inspection, because they're not familiar with the system, they may not understand it as good as the person who originally installed it. It's definitely not required, and sometimes it's better to find someone else because you get a better price or a third opinion. But it's an option. And some manufacturers will, or contractors will offer kind of a maintenance plan or inspection. So something to consider and then evaluate whether that's the best route or if it's better to go with something else. So in conclusion, we talked about the fall protection plan, the different parts of that plan and what's required in it. We talked about system benefits and limitations. We talked about anchors, what's required for anchor strength, some field considerations, and then different things to ask manufacturers and contractors. I would like to remind you that there are other resources available online. You can go to the AMHSA website, the QR code here. So this is the website for this aquatic health and safety awareness campaign. It's got the recordings of the first two webinars. This webinar recording will be posted as well. There's also a bunch of other resources available. One thing to note, if you're an AMHSA member, you will have access through the AMHSA store to a variety of CSA standards. They have some standards purchased there that you can view. And information about that will be emailed out. If you want some training, so AARFP and AMHSA have partnered together to have 4 different program certificates. Some of these might be of value. There's the Aquatic Safety Operator Certificate, the Arena Safety Operator Certificate, the Building Maintenance Safety Operator, and then the Parks and Sports Field Safety Operator. So all of those provide more training on a variety of different topics, not just fall protection, that will be related to those different areas. And then if you're using or implementing a fall protection system or plan, I'd recommend getting an in-depth fall protection training. So you can get fall protection training as a user, you can get training as an inspector, you can also get training as a competent person to develop the plans and procedures on how to use the systems. So here's our contact information. Again, I'm from High Engineering. Here's our phone number, contact information. There's a QR code to our website. And then there's also the contact information for AMHSA. So if you want to contact High Engineering or AMHSA, there's our contact information. We're happy to help answer any questions. So I'd like to say thanks for listening. It's been a pleasure having everyone for these 3 webinars. That would be all, and I'd be happy to take any questions after this.